Hello, I'm June Park, and today I'm gonna introduce about autoscaling system for predict demand of resources and respond to barrier in forecasting. The presentation consists of 4 parts: introduction, proposal, implementation, and conclusion. First, the main goal of our project is to develop a system that can predict future resource demand based on previous data and adjust resource in advance. And in detail, there's 2 goals. First one is the predictions of demand for several resources, and the other one is to respond to failure to forecast resource demand. So, for demand prediction, server utilization is collected periodically from monitoring server, and resource demand is predicted by using deep learning model and make plan. And for response to failure, server utilization is also checked periodically after prediction process, and proper number of resources is calculated and applied. So, this is the project structure. There are 3 parts in this system. First, collect data from target clusters and send them to Autoscaler. Second, perform forecast or track process in Autoscaler. Third, apply adjustment of target cluster. For prediction demand, bi-LSTM model is used. This model resolves long-term dependency problem that RNN had, and by using 2 LSTM layers, both past and future data were used. In check phase, check if the provisioned number of resource is enough to meet the current demand. So, first, new number of VM is initialized at the number of VM currently in use, then get threshold of network throughput. Finally, get the proper number of VM based on input. If the result is different, then make a new plan, else do nothing. In planning phase, plan for adjustments was made based on results from prediction or check. So first, get threshold of network throughput, and then get proper number of VM for next period. If more VMs are needed, then to scale up, or less VMs are needed, then to scale down, else do nothing. For training, we've used BitBrain's dataset, which includes performance metrics for 1750 machines in distributed area. It consists of fast storage and R&D files, and fast storage was used, which servers are used by frequently used programs. Then, memory uses and network receive throughput was picked, which has highest correlation based on pairs correlation. And normalization is applied. Also, data was divided into training and test. Model was configured based on these parameters, and right one is model loss for training. And this is the result of prediction. As we can see, it didn't cover perfectly, especially when the demand is high. And to measure efficiency in resource provision, system-oriented elasticity metrics presented by the spec organization. First one is the under-provisioning metric, calculates the number of required VMs that must be provisioned to meet the current demand. Second one is the over-provisioning resource metric, calculates the number of exceeded VMs provisioned by the autoscaler, and both of them are normalized by the measured time. And this is the result. Before measure, we've made an assumption that network throughput per VM is 500 kilobytes per second, and limitation is 60%. It shows improved performance with the track process. In this graph, we can compare both results, and with track process usually worked well than the other one. Cooling time, which is waiting period after adjustment, is also applied because it takes about a minute to provision new resource. And we assume that missed part in check graph was caused by this cooling time, since a lot of requests occurred in a short period, even shorter than cooling period. So, It was difficult for it to predict the demand for resources that changes rapidly over time, but just adding responsive barrier of prediction made meaningful improvement in provision efficiency. As there were some parts that were not covered even though the check process was included, further research on how to supplement the details is needed. And here is reference and acknowledgement. Thank you.